Hi everyone. Today we will be discussing kidney exchange and how algorithms, specifically Gale-Shapley algorithm, determine which patient and donor exchange a kidney. When breaking down the kidney exchange problem, there are some factors we have to take into consideration. So more people and donors means that it's complicated since more people and donors leads to an uneven distribution of blood and tissue types. So another thing is when we visually represent this scenario, we're going to represent patients and donors as nodes, and we're going to represent mutually compatible node pairs as edges between two nodes.
In this algorithm, each pair contains a patient that needs a kidney and a donor that is willing to donate their kidney to their loved ones but cannot due to incompatibility. According to Alvin Roth, using Gale-Shapley algorithm, we are able to match every donor that is capable of donating to a patient from another pair who is compatible to take their kidney. The figure demonstrates this algorithm.
So an ethical problem that could arise is the fact that we don't want to add extra stress on the donor, as a kidney exchange is a stressful situation by itself. So a solution to this problem is to give the donors an option even before it is known whether or not the donor is compatible. So the stakeholders involved are the donors, so the people who are donating the kidney, the patients, people who need the kidneys, and hospitals, so the organizations that represent the donors and patients.
One potential bias is the failure of one person's kidney after the transplant. This would show a disfavor in the group of people who received the failed kidney. The algorithm is supposed to check if the kidney is compatible with the blood and tissue type, but if one of the reasons why the kidney failed was one of these criteria, then it's the algorithm's fault. The blood type themselves also contain bias, because O type can only take from O types, whereas all other blood types have two or more options. In this situation, there are multiple instances where recipients and donors are unmatched due to a lack of compatibility. It might be due to the unfair acceptability of blood types. One mitigation of this could be having a limited and unequal amount of blood and tissue types in donor and patients.
Alvin Roth came up with another great mitigation, which would include a non-directed donor who doesn't need a kidney in exchange. This donor can help a patient who couldn't receive a kidney, in turn matching an available donor in the graph to a well-compatible patient on the wait list, which results in saving more lives.
Another algorithm that could solve the kidney exchange is the top trading cycles algorithm. The issue with this is that the cycles that it produces are much longer than Gale-Shapley, and larger cycles is more difficult because it requires more energy to conduct simultaneous surgeries, as well as it increases the chances of donors from backing out. If a donor backs out, then the patient cannot participate in any more kidney exchanges.
These are the references we used for the video. Thank you.